In this video, we're going to go through how to calculate the concentration of ions in solution. Typically for these types of questions, we're given some ionic compound that's in solution, and we have to write a dissociation equation, balance the dissociation equation, and then we can figure out the concentration of ions. Just to explain the shorthand that's going on in this line here, the square brackets, that just means the concentration of whatever's inside of those square brackets. Okay, so this statement here is just saying that we're going to be given some concentration of some solution. We need to write out a dissociation equation and then calculate the concentration of the ions that are asked for in the question. So remember that ionic substances, those are going to exist as crystal lattices. Molecular compounds do not exist as crystal lattices. It's only ionic substances. And also, just particular to ionic substances, those substances are going to be what dissociates. Molecular compounds are the ones that ionize. Okay, so a dissociation equation is one in which the solid ionic substance breaks down into the ions that make up the crystal lattice. The products of a dissociation reaction always include a cation, which is just a positive ion, and an anion, which is the negative ion. So that's pretty important to know what a dissociation equation or reaction, they're referring to the same thing here. Okay, so if we were to make a template for a dissociation reaction, it would just be some ionic compound, and we can write this as aqueous just to kind of be like the snapshot right before it dissociates. Okay. And since we're writing aqueous here, we don't necessarily have to write water above the reaction arrow here. Okay, but it breaks apart into the cation that makes it up, which is going to be in the aqueous state because ions are always aqueous, plus the anion. Now it doesn't matter if you write the anion first or the cation first, just so long as you have the correct cation and anion. Now keep in mind, for dissociation equations, you only ever get two products. If you are writing more than two products, you are doing something wrong with your dissociation equation. Okay, so sometimes you're going to be asked to calculate the concentration of an ion, and for this you're going to need a balanced dissociation equation. So let's say we'll highlight to calculate concentration of ion, you need a balanced dissociation equation. So we're given the start to a dissociation equation. So here we have our ionic compound, and it produces our cation and our anion. So this is a skeleton chemical equation, which means it's not balanced just yet. So we need to go in and balance it. So arbitrarily, I'm just going to start with aluminum here, and I notice that we have 2 atoms of aluminum going in, not atoms, 2 aluminum ions going in, but right now we only have 1 coming out, so we just need to fix that there. So I'm going to write a 2 so that my aluminum ions are balanced, and then here I notice that I have 3 sulfate ions going in, so I need to have 3 sulfate ions coming out. Alright, so now that's balanced, and just below it here it's saying, okay, according to our balanced equation, for every 1 molecule of aluminum sulfate, you're going to get 2 aluminum, that should be aluminum 3+ ions, and 3 sulfate ions. So you're going to need to use a ratio, like the mole ratio, to convert between the concentrations of each ion or atom. It should actually be just ions. Alright, so the ratio is going to be called the mole ratio, which we've talked about briefly before. Now this is just a slightly different way to represent the mole ratio. Okay, so mole ratio is equal to the moles of the required substance, so what you're looking for, divided by the moles of the given substance. So the numbers that you put in the mole ratio, they come from the coefficients of a balanced chemical equation. That's why you first need to balance the equation before you get to the mole ratio. Okay. Another way to just state this ratio, which may be a little bit more helpful here, is your mole ratio is just the substance that you want divided by substance that you're given in the question. Okay. Now, to do these questions in which you need to calculate the concentration of ions, it can be broken down into 2 steps. So step 1, write a balanced dissociation equation. Step 2, use the mole ratio to calculate whichever concentration of ions that the question's looking for. So for example number 1 here, concentration of aluminum sulfate is 1 mole per liter. We're asked to figure out the concentration of both aluminum ions as well as sulfate ions. Okay, so I'm just going to be copying down the coefficients that we have figured out from before. Keep in mind, whenever there's not a number explicitly written for a coefficient, it's assumed that it's 1. If that really bothers you to leave that blank, you could put a 1 right there, but make sure that you know that if a number isn't written there, do not assume that the coefficient is 0. That is not true. If the coefficient is not written, it's just a 1. Okay, so we have 2 and then 3. Alright, so there's our balanced dissociation equation, and to figure out concentration of aluminum ions, we're going to start off with what we're given, which is concentration of the aluminum sulfate solution. Okay, so that's going to be 1 mole per liter. And I'm just writing the identity of the substance so you can kind of see why the mole ratio works out. So you always write out what you're given first and then go times by fraction sign. Okay, so what we're given is aluminum sulfate. Okay, and the coefficient for that is just 1. And for this question, what we're looking for is a concentration of aluminum 3+. Okay, and the coefficient for that is 2. So essentially what we're doing is we're taking 1 multiplied by 2 divided by 1. Okay, so that's going to give us 2 mole per liter of aluminum 3+. Okay, so since we're not writing this in a chemical equation, I'm fine with you guys not writing the state for this. However, just know that whenever you do write a chemical equation, you should always be writing the states for all chemical substances in the chemical equation. Alright, so the reason why the mole ratio works the way it does is if you treat the identity of the substances kind of like units, notice how we have the exact same thing on the top and the bottom, which I've circled here. So those cancel out, and we are left with aluminum 3+. So that's why we can use the mole ratio to convert from the concentration of one substance to another substance. Okay, just keep in mind that the mole ratio can be used to convert from one substance to another substance if your units are either moles, liters, or mole per liter. Those are going to be what you need in order to use the mole ratio. So put a box around my final answer. One thing that I didn't say explicitly is that I already have this in the correct amount of sigdigs, because for my question, the number given has 3 sigdigs, and my answer is in 3 sigdigs. Okay, so remember those trailing zeros, they do count as significant digits. The trailing zeros are any zero that comes after a non-zero digit. All right, for the next question, figure out the concentration of the sulfate ions. So first off, I'm just going to start back to what we were given. So 1 mole per liter aluminum sulfate times by fraction sign aluminum sulfate, and we want the sulfate ions. So coefficient from balanced chemical equation for sulfate ions is 3, and then for aluminum sulfate it's 1. So we're going 1 times by 3 divided by 1. So that's going to be 3 mole per liter. I'm already putting this in the correct amount of sigdigs. Okay, and since aluminum sulfate's canceled out, the identity of our substance is the sulfate ions. Okay, so make sure that you always know what substance you're talking about when you're doing the calculations, because you're going to find that helpful, especially when we start getting on to more complicated calculations. All right, example number 2. So if the concentration of, we'll say, a solution of barium hydroxide is 2 moles per liter, what is the concentration of each ion? All right, so just as a side note here, if you do look up barium hydroxide in your solubility table on your Chem 30 data booklet, what you're going to find is that, so hydroxide's here, barium is a group 2 ion, so it doesn't fit in group 1 ion or ammonium, so it's going to fit under most. So barium hydroxide is insoluble in water. However, for the sake of this question, we're just going to say that it is soluble just for this question. Okay, so just keep in mind, if a question tells you that you have a solution of something, even though it may be insoluble in your solubility table, just go with what the question says. But just know it's not always perfect. Okay, so balanced chemical equation. So barium hydroxide. So I kind of jumped the gun here, but the reason why I'm writing it the way I am is because barium has a 2+ charge, hydroxide has a -1 charge, so I just went ahead and did crisscross applesauce by bringing down the numbers there. Okay, not the charges, just the numbers. And since we have a solution, how we translate the word solution into our chemical equation is we're going to write that this is aqueous. Okay. And then we go to our cation, so barium 2+, aqueous, plus hydroxide. And then we need to make sure that this is balanced. So I have 1 barium going in, 1 coming out, 2 hydroxides going in, and now I have 2 coming out. All right, so that's balanced. We have all our states, we have all our charges, so we're good to go on that. All right, so figure out the concentration of barium 2+. So let's go back to the fact that we know the concentration of our barium hydroxide solution is 2 moles per liter. That's where I'm going to start. Okay, oh, not quite yet. Barium hydroxide times by fraction sign. Okay, so what we want is the barium 2+ ion. So I'm going to write that up top. What we're given, barium hydroxide. Okay, so coefficient in front of the barium 2+ ion is 1. Coefficient in front of barium hydroxide, that's 1. So concentration is just 2 moles per liter of barium 2+. And that's already in the correct amount of sigdigs. For the concentration of hydroxide, once again, I'm going to start with what is given to me in the question. The reason why I'm doing this is because if you're doing these types of questions on a test, technically you could start from here and just use the mole ratio, and your given substance would be the barium 2+ ion, and your wanted substance for this question would still be the hydroxide ion. However, if you're doing this on a test and you get this first number wrong, that's going to mess up your answer for the second question. So that's why I recommend, just for these questions, start with what the question gives you. So 2 mole per liter barium hydroxide times by fraction sign. So we're given barium hydroxide. We want hydroxide, so we got a 1 coefficient there, 2 coefficient there. So we're going 2 times 2 divided by 1, which is going to equal 4 mole per liter of hydroxide ions. Okay, and those cancel out, same with those. And that's already in the correct amount of sigdigs. So we are done there. For the next example, if the concentration of the hydroxide ions is 3.8 mole per liter, what is the concentration of barium hydroxide? So we're still using this dissociation equation to answer example number 3. Okay, so I'm going to start off with the hydroxide ion concentration, so 3.8 mole per liter. Hydroxide times by a fraction sign. So we're given the hydroxide ions, and since it says what is the concentration of barium hydroxide, that's what we want. Okay, so looking back at our dissociation equation, 1 coefficient there, 2 coefficient there. Oh, that wasn't very neat. So you're taking 3.8, timesing it by 1, dividing it by 2. Okay, so that's going to give us 1.9 mole per liter. It's already in the correct amount of sigdigs because, actually, I'll point to the number in the question there. This number has 2 sigdigs, so our answer has to have 2 sigdigs. All right. Example number 4. Actually, I'm going to put a box around that before I move on. Example number 4, what is the cation, so the positive ion, concentration of a 0.125 mole per liter solution of ammonium phosphate? Okay, so we have a different solution now. So now we need to write out a new dissociation equation. So ammonium phosphate, ammonium, that's one of... Actually, both ammonium and phosphate are going to be found in your table of polyatomic ions. Ooh. So ammonium is right here, and then phosphate is right there. So ammonium has a 1+ charge, phosphate has a 3- charge. So ammonium, phosphate. All right. So +1, -3. Obviously, 1 minus 3 is not 0. So we got to do crisscross applesauce. There we go. So now that is balanced. Okay, and since it says a solution of ammonium phosphate, then we got to go aqueous. So always remember to write your states for every chemical substance in any chemical equation. All right, so now we got to dissociate it, so break it up into its cations and anions. Arbitrarily, I'm just going to put cations first. So cation is ammonium, aqueous, so you could write +1 like that, or just plus, same thing, plus phosphate. So we have 3 ammonium going in, 3 coming out. Oh, I better write the charge there. And 1 phosphate going in, 1 phosphate coming out. So that is completely balanced now. All right, so let's start off with our given. So 0.125 mole per liter. What does that belong to? Ammonium phosphate. PO4 times by fraction side. Okay, so we are given ammonium phosphate. And what we want is the cation concentration, so that's the ammonium one. So coefficient for ammonium, that's 3. Coefficient for ammonium phosphate, that's 1. So we're taking 0.125, timesing it by 3, dividing by 1. Okay, so that's going to give us 0.375 mole per liter of ammonium. Okay, so this number here is in 3 sig digs. My answer is in 3 sig digs. I'm done. Alright, so for example number 5, it starts to get beyond the scope of Chem 20, so we're going to omit this one. Don't worry about trying to find the concentration of an ion once you've mixed 2 solutions together.